We've done Hipot testing on the bolt, testing between the voltage input and the user accessible USB and CT inputs on the other side to test the barrier, isolation barrier across the bolt. Today we're going to be doing a different type of Hipot test. This measures the isolation from the voltage front end to any sort of user accessible area outside the bolt. If you're holding the bolt while an impulsive transient occurs or you're holding the CTs, we want to make sure it's safe. And this is a test that you also will perform on the bolt. So let's check it out. We'll connect the voltage front end, and here we have all the voltage inputs tied together to the hot side of the Hipot tester, and on the other side we have the CTs. And to simulate a person's hand, we are going to use copper foil tape. So take this copper sheet, wrap it around the bolt tightly, and this simulates a person's hand that might be gripping the bolt while an impulsive transient occurs. So we're going to take the return of the Hipot tester and actually connect it directly to the copper foil to see if there are any hidden creepage or clearance paths to the isolated side of the bolt. So we're going to start at 4 kV, the UL minimum requirement, for 5 seconds, and we're allowed a 0.5 milliamp of leakage current. And we easily pass at 48 microamps. Let's go beyond the minimum to 6 kV. And we easily pass at 80 microamps. Now we're going to go all the way to 8 kV to make sure we have a lot of margin in this for the safety test. And we also pass at 8 kV. Now let's try this in a different configuration. You may be holding the CTs or the voltage connector. So we're going to move the copper foil to a different position. All right, we're going to start back at 4 kV. And here we have the foil connected around both the flexible CTs themselves and the cable that connects the flex CT elements to the bolt in case you're holding either one of those. We easily pass at 4 kV with 32 microamps. Testing 6 kV. And we easily pass, and we'll go to 8 kV to make sure we have a large margin here for safety. And we pass at 8 kV. And finally, we're going to test the other end of the bolt, the transition between the voltage cable and the bolt housing itself. Now we've moved the copper foil to the voltage side of the bolt, and again we're testing for any sort of hidden creepage or clearance problem that allows a conductive path from the outside of the bolt through the voltage connector into the high voltage section of the bolt to make sure we have a good safety margin. We're going to test at 4 kV. And we easily pass with 55 microamps of leakage current. Go to 6 kV. And we passed there at 6 kV. And now we're going to try 8 kV. and we also passed at 8 kV. So we've passed the foil Hipot test in various configurations at the minimum voltage required by UL 6110, and also all the way up to 8 kV. This ensures user safety if someone is holding the bolt and an impulsive transient occurs. Of course, if you're using the bolt with energized conductors, you should still wear gloves, wear the appropriate PPE as required by your utility, but we have an extra layer of safety for those sort of situations.